Let's look at the difference between raster or pixel-based graphics and vector graphics. So a photograph, if I zoom into it, eventually I'll see these individual little squares that make up the image. And you can see all the variations of color. A pixel-based graphic can contain millions and millions of different colors in it. This makes it really great for capturing all kinds of subtleties of light. I can see the softness in the clouds. I can see the illumination through the bird's wings. All these variations of pattern. It's really very beautiful. There are a few downsides to pixel-based graphics, or limitations. One of them being, so this bird, if I was to try to move it, this bird is just a set of squares in this image, and you can't manipulate it or move it without going through the selection process. It's also a specific size. So this image is 5,184 pixels wide by 3,456 pixels high, which literally means there are that many pixels across and that many pixels down. Now, if I was going to, take a very small image that was, say, a thumbnail for on a website, and then enlarge it to a really big image, let's say I put it on the side of a bus, then it would be really soft and fuzzy, or it wouldn't fit. And then these very large images, let's say I want to keep as much I want to have very high quality images. I'm going to save. I have a 100 billion megapixel camera, and I want to save all that information. It's going to save, it's going to use a lot of storage space. It's harder to transfer back and forth. You can't just email it to somebody. If I was trying to put it on a website without resizing it, it would take forever to load. So let's now look at vector-based graphics. Now, we've actually used vector-based graphics without describing them as such. So, for example, let's take a look at the simplest one first, a square. If we use the square tool to create the square, assuming that we have it set to shape, you see that there are little points on the corner, and these points are what are defining the square. It's not defined by rows and rows of little pixels, but by these points in these corners. It's really a mathematical model. Now I can actually go in and move these around. Now let's look at another one. I'll use an ellipse. So an ellipse is also made of 4 points, except instead of connecting lines, instead of connecting straight lines, it's connecting curved lines. And if I select these points, you can see that this handle comes out, and this is called a Bezier curve, and these handles control the curve. So I can keep that one point in place here and modify the handle, and then the curve is modified, while the endpoints are still staying in the same place. I can also move the endpoints around. I can make these very beautiful shapes. Now, because vectors are mathematically based, you're going to tend to get these very beautiful smooth lines. And that's one advantage of vector-based graphics, is that they tend to you're going to create these very smooth shapes. You'll notice that when you've used the raster selection tools, like say the magic wand, for example, there's a tendency for it to break up and get lots of awkward little shapes and little rough edges and things like that, because it's trying to find its way around, this complex, arrangement of pixels. So, I can look at this, and to me, I see this as clear. I can see here's the sky and here's a bird's wings. But if I zoom in close, the computer is trying to decide, is this, where is the wing? Is this part of the wing here, or is it over here? And that's why you get all these rough edges when you're working with raster graphics. Whereas the vector has this very clean, smooth line. The smoothness, though, can also be a disadvantage because it's going to, if I was, for example, working on this outline, it's going to want to tend to lose detail and kind of smooth things out that should be pointy, especially like around these beaks and things like that. So that's something we're going to be mindful of. We'll look at that in the next video.